Okay, welcome back. Hopefully you're having a fantastic day. Today we're going to talk about how to cut this groove for the Talon grips in the 5-inch Tormach soft jaws. We're going to discuss how to use wear so we don't have to go back to the computer 25 times. Stick around. It's going to be stupendous. Okay, we're going to start here in the model. We're first going to turn off the Talon grips that are going to go in there so we can just get the straight groove. And we're going to go ahead and flip over to the manufacturing side. And we're going to do a setup. This setup we are going to do, we can select our model. Oh, there we go. And then we can, the origin's actually going in the proper direction for us. But we're also going to make this a from solid and select the solid because we've already machined this in Ops 1 and 2. I've noticed that for some reason in the latest update, Fusion has lost that I live in America and have to use the inch system. So I'm going to set that back to inches. So first thing we're going to do is we're going to adaptive clear this. We probably could just blow through with a 3/8 end mill and get what we want, but I'm going to show you guys a cleaner way of doing it. So I'm going to select for my tool libraries the standard Haas library that we use, where the number 4 tool bit is or the number 4 drill bit is a 1/4 inch end mill. We're going to grab that edge, and we are going to reduce this. I'm happier with it. Seems to run better on my machines at 0.8, and I'm going to leave OK. And there we go. It did an adaptive and cleaned up most of that. So the next step is we are going to do a contour of this line and that line with a 3/8 end mill. And why do I choose 3/8? So let's first hop over to the desktop and let's take a look at the part. So here is our Talon grip soft jaw. And these Talon grips have to fit in this groove. Now, if we take a standard 3/8 cutter, which here's the 3/8 cutter, and we run this in here, the computer is calculating that this is 0.38 of an inch in diameter, which it should be within tolerance. It is probably not exactly 3/8. It could be over. More likely, it's slightly under, like instead of going 0.375, it may be 0.3745. But anyways, that small variance, especially when you add it to both sides, could make our groove too narrow. So the way to cleanly do this is we're going to use wear, which lets us, it will calculate this as a 3/8 cutter, but then when we cut it and we try to fit this in and it doesn't fit, we can go in and adjust the wear, which will allow the computer to say, oh, the cutter's actually slightly smaller. I need to shift the tool path slightly to the right or to the left, depending on which way you're cutting, and cut again to get to the exact size they want. So it's basically a way of telling the computer that the cutter is slightly undersized, and we want you to take that slightly undersized into adjustment. It also allows us, if we program a perfect 0.5 width, and these are not exactly 0.5, they're slightly bigger, we could just, a couple of keystrokes at the controller, we could open this up without having to go back, adjust the CAD file, repost a file, go out, run it, find out it's still too small, and then go back. Now, we've chosen a 3/8 cutter for this project because this is 0.5, if we accounted for the wear, and we shift the cutter over for this pass, it can leave a little ridge behind that then we have to tell it to go back and clean up. If we just switch to a 3/8 cutter, which is a tool standardly loaded in our machines, we can ensure that when we cut on both sides, even when we add wear, it's going to not leave a ridge. So back in the model, we're going to choose a 3/8 end mill out of our standard tool library, which is our tool number 2. We are then we've selected the geometry, the height doesn't change. We need to change from compensation type to in computer to using wear. and then we should be able to click OK. Now, in the computer, it's going to show us nothing. Like, we're not going to see the wear. Oops, I'm sorry. I was trying to simulate that. If we hit play, there we go. Let's speed this up. And then it's going to come back and clean up that edge and come back and clean up this edge. The computer knows that it's a 3/8 inch cutter and it doesn't have a theoretical wear into it, so it won't adjust for it. Now, in real life, we're going to cut the first one. We would then figure out how much wear, type it in, and then we can make hundreds of these before we would need to adjust that. Considering in the student environment that you're in, you're only making one. You're going to cut it, probably undersize, and then make the adjustment and have to recut this contour probably twice. So now that we have that done, the next thing to do is to come back and drill these holes. So we're going to go ahead and switch to the drill. And we are going to select from the tool library the Talon soft jaws, and we are going to select drill 19. You download this drill library from Schoology. And we then select here. I can select the same face so it'll grab each one. And I'm actually going to push the hole a little bit deeper, like 0.05 deeper. Oops, that's a negative 0.05 deeper. Okay. Now the reason why I did that is so when I cut the tap, there is space at the bottom of that hole, so I'm not running that tap to the bottom of the hole, risking it breaking off. The reason why my talons are offset by 1 is because that's what happened on the hole on the other set of talons that I have in the machine right now. They broke a tap off in this hole, and we can't get it out. So we offset this in by 1, and the block is slightly offset in the jaws. Not perfect. I probably should move this one in 1. It would be better. So now it's time to tap. We select drill again. We're going to select the tapping tool from the same tool library. We are then going to select one, select all of them, and we are going to stop this 0.025 up from the bottom, which we are using a 1/2 inch bolt going in here to hold these on. The talons are a 1/4 inch thick. We've made the hole 0.35 deep, so we're only going down 0.325, so there should be plenty of room for the bolt length in there. So we can go ahead and click OK. And if we turn it to the front and we switch between here and here, you can see there's clearly a difference between the two. That extra 0.05 has gotten me all the way past the bottom of the hole because remember, it's controlled off the tip. Last thing I forgot to do with the setup was edit this and create a offset, and this is supposed to be G154P8, so that's P2, so we're going to use a number 8 for our work offset, and we are going to use the number issued to us for your school. The program number is the number I've told you should use. So we click OK, we post it out. Oops, I named it the wrong thing, but we'll just post it to the download so I can throw it away later. And here's our code. We'd run it on the at simulator before we go out and run it on the Mini Mill 2. Hopefully you learned something. Thanks for watching. We'll catch you in the next one.